When we're taking measurements in science, we want to make sure that all of our readings are not only accurate but also precise. So let's first define these two words. The easiest way to remember accuracy is to think of if you were throwing darts at a dartboard. If you were to hit the bullseye every time, you would be very accurate. So on your paper, go ahead and write down the definition of accuracy is to actually hit the correct location or your target. Okay, so accuracy means to be correct or to be on target. Precision, on the other hand, means that you are always getting similar results. So you might not always hit the bullseye, but you are always hitting in the same general location. A good word to think of with precision or being precise is to be consistent. So although a measurement that you take in class, let's say the measurement is supposed to be 15 centimeters, but every time you take a measurement, your ruler comes out with a measurement of 14.7 the first time, then maybe you get 14.5 the second time, and then the next time you get 14.4. You're not exactly on what you need of 15, but every time you are very consistent. So in this case, you're precise, but you're not exactly on target, so you're not exactly accurate. This is a diagram to help you understand the difference between being accurate and precise. In the first box, you can see that every single time the person is hitting the bullseye. That means that they are at the correct location that they want to hit, so that means that they are accurate. And every single time they're hitting the bullseye. So they are precise, which means that they are constantly hitting in that same location. They're getting the same results every single time. If you were to be inaccurate, you might be a little bit off to the left here, as you can see in this image, but you keep hitting that same spot. So you are precise, you keep hitting that same location, you get those same numbers every time you take a recording, but you're not quite in that correct location, so you are inaccurate. If you were to be accurate, but imprecise, in this image down here, you can see that we're getting kind of close to the bullseye, but we're kind of all over the place in that bullseye general location. A couple times we're hitting the bullseye. So you're getting close, you're accurate, but you're kind of all over the place. Sometimes you're high, sometimes you're low, sometimes you're a little bit to the left or a little bit to the right. And then finally, if you're both inaccurate and imprecise, your bullets are kind of hitting all over the place. You're off from the target, you're not hitting them in the same location. So take a minute and go ahead and on your notes page, make a recording of these different examples of what it means to be accurate and precise or inaccurate, but still precise, accurate and imprecise, or both being inaccurate and imprecise. So here are some examples for you. Let's say that the correct reading on your graduated cylinder should be 12.4 milliliters. And the first time you take data, you get 11.5 milliliters, 11.1 milliliters, 12.9 milliliters, and 13.1 milliliters. The next time you go ahead and take that data is example number 2, and the next time you get 11.8, 11.7, 11.7, 11.8. And then finally, the third time, you get 12.3, 12.4, 12.3, 12.4. Take a minute, pause the video, and think about which of these are accurate, which of them are precise, which of them are both accurate and precise. Pause the video here and see if you can figure it out. So on the first one, we're kind of all over the place. We got 11.5, 11.1, 12.9, 13.1. We're not very close to our correct reading, and we're also not having readings that are similar to each other. So we would say that the first time that we did this, we're not accurate or precise. The next time, we get readings that are all similar to each other, but we're not exactly on target. So we're going to say that for this one, we're precise, but we're not being accurate. And then finally, the last one, you should have said that you were both accurate and precise. All of the readings are similar to each other, and all of them are pretty much on target with what we're looking for. So the third time, you would have been both accurate and precise. Finally, the last thing that we need to practice in this screencast is rounding. Rounding with chemistry, we're going to make sure that if we are 0.5 or higher, we're going to round up. If we are 5 or lower, we're going to round down. So on your paper, it says to round the first ones to the nearest tenth. So the first thing we have to do is we have to make sure that we know where the tenths place is. And your tenths place is going to be the first place after the decimal point. So we're going to be rounding to that location. So on our first one, number 1, we've got 12.642. So we're going to look after the 6 here, we have a 4, and so that means that we are going to be rounding 12.642 down to 12.6. On number 2, we want to round to the tenths place, which is the 1 right here, and so if we look at the space after it, we have a 0. So it's not higher than 5, so we're going to round down to 29.1. Now, on the third example that we have here, if we take a look, 2.49. This 9 means that we're going to round the tenths place up to 2.5. So notice how, with all of these, it wants us to round to the nearest tenth. Every single one of our answers should have to the tenths in the decimal place, and that's it, not any farther than that. Take a minute, pause the video, and try to round number 4, 5, and 6 on your own, and then check your answers back with me. So number 4 you should have rounded to 3.4, number 5 to 5.2, and number 6 to 89.4. Next we're going to round to the nearest hundredth. So that means that we want to look at the second spot after the decimal point. So take a minute, pause the video, see if you can decide on what you would round 1 through 6 on this section to. So remember, for each of these, we're rounding to the 100ths place. So you should have gotten 23.99, 3.71, 4.45, 44.04, 999.47, and 7.44. If you didn't get these answers, look back and see where did you go wrong. On this next set, we're going to go ahead and round to the nearest thousandth. So that's going to be the third space after the decimal point. So I'm circling each of them here. We're going to round to that decimal place. Take a minute, pause the video, and round to the correct number. Go ahead and check your answers. The most difficult ones were probably number 1 right here and number 5 right here. Because the 8 is higher than 5, we've got to round the 9 up, but then we've got to round the next number up, then we've got to round the next number up. So we actually have to round this to 1.000. We have to make sure we keep all the way to the thousandths. The other one that might have been a little bit difficult is number 5 here. Because the 9 is there already, we have to round up because of the 7, so that means that that rounds up to a 3 on the 2, but we got to make sure we keep that thousandth place there. So we would round that up to 0.230. Go ahead and try the rest of the rounding on your own. We'll go over it together in class.